Okay. Hi, I am Dr. Chanupati Tirupati, working as Associate Professor, Head of the Department Civil Engineering, Sashi Institute of Technology Engineering and Tadepalligudem. So I am going to discuss about fluid mechanics. This is one of the very important subject, as we know what is essential life for essential resource for human life. So first we need to understand what is fluid mechanics and what is the applications of fluid mechanics, that I will discuss in this lecture. So in this lecture actually I am going to discuss about what are the course objectives and course outcomes, and what are the syllabus, what is the syllabus, and then what are the main applications of fluid mechanics and why we need to study the fluid mechanics. Those things we will discuss. So when it comes to the fluid mechanics, the prerequisite for this course is engineering mechanics. So first actually we need to understand the equilibrium conditions of the engineering mechanics, that is like sigma h is equal to 0, some of the horizontal forces will be 0 and some of the vertical forces equal to 0, and some of the movements when the body at static equilibrium condition, some of the movements about that particular point will be 0 and some of the horizontal forces will be 0, some of the vertical forces will be 0, and these basic equilibrium conditions are very essential for the fluid mechanics. Along with these equilibrium conditions, other engineering mechanics concepts also required for the fluid mechanics. This course is we are offering as a professional electives, and it is offered to the second BTech first semester civil engineering students. So the number of hours we are planning to complete this complete syllabus is about 50 hours. Yeah. So what you are going to learn from this subject? So here first we are trying to understand the properties of the fluids. First we are trying to understand the properties of the fluids. First we are trying to understand the properties of the fluids and fluid statistics. So what about the properties of the fluids means, that we will discuss in detail what we are going to cover, and also we are trying to derive the equations of conservation of mass and its applications, and also we are trying to solve the kinematic problems and finding the particle paths and streamlines. So in detail we are discussing about what is streamline, path line, and also on what is the kinematic concept we are going to apply here. And also next we are trying to use the concept of continuity equation and try to understand the fluid mechanics problems with the help of continuity equations and Bernoulli's equation and turbulence, and apply the same to the problems. And next we are trying to understand the laminar and turbulent flows. After that we are trying to understand how we are going to apply the Bernoulli's equation or continuity equation in measurement of the flow. So later in the last unit we are going to understand what is the boundary layer theory, what is the concept of boundary layer theory, how we are going to use this boundary layer theory. Yeah. So when coming to the syllabus, when coming to the syllabus, the first unit is discussing about basic introduction like fluid properties and measurement of flow by using the manometers or pressure measuring devices, and also we are going to deal with hydrostatics. Okay. So in first unit we are discussing about dimensions and units. So we all know that there are three basic dimensions, meters, length and time. So M, L, T. So this we will going to discuss in the first unit, and also we are trying to understand the physical properties of the fluid. So in the first unit we are discussing about what is fluid and how it is different from the solids and liquids, solids and gases. And also we are discussing about the density, specific gravity, viscosity, surface tension, bulk modulus of velocity, vapor pressure. These are the important concepts or important properties of the fluid. See, fluids covers with both liquids and gases. These things we are discussing. what is the important properties of the fluids, and also we are trying to understand the vapor pressure and their influence on the fluid motion. So how the vapor pressure will influence the fluid motion, and later we are discussing about the pressure at a point and Pascal law. So the Pascal law is very important concept actually, which is used for hydraulic machines to lift and hydraulic lifters. To design the hydraulic lifters, we are going to use this Pascal law, and later we are discussing about hydrostatic law, and then atmospheric, gauge and vacuum pressures. So we will try to understand what is atmospheric pressure and what is a vacuum pressure and what is a gauge pressure, and how they are going to, how we are measuring this atmospheric pressure or gauge pressure or vacuum pressure. So this gauge pressure, so whatever the pressure we are measuring with respect to the atmospheric pressure, that you can call as a gauge pressure. So this actually this pressure we are using to measure the pressure at any point. And later after that we are going to discuss about the pressure gauges like manometers and YouTube differential manometers and differential micrometers and all. In the second part of the first unit, we are trying to understand the hydrostatics. So here we are dealing with what happened when the fluid at rest. So when the fluid at rest, how the forces are acting on it, that we are trying to understand, and where the location of the center of pressure, means where the pressure will act. So here to understand the fluid at rest, we are talking about four objects. One is forces of a submerged plane, and then horizontal plane. When the horizontal plane submerged in a liquid, what is the pressure acting on the plate, and what is the center, where it is acting, center of pressure, and also when what happened when the inclined surface or vertical surface submerged in a liquid, and also curved surface. So these are the things we are discussing about the first unit. So in the second unit, we are trying to understand the fluid kinematics. So fluid kinematics is we are considering the forces acting on a fluid, so without causing the motion. So whatever the forces causing the motion, that we are not accounting the kinematics. Other than that, we are considering the other. We will study the fluid motion without considering the force which causes the motion, that is called as fluid kinematics. So here we were talking about the fluid flow, how it will be, what is the streamline, what is the path line, and streamline and stream tube, these things we will discuss. After that, we are trying to understand types of flow or classification of the flows, like steady flow, unsteady flow. So what is steady flow, what is unsteady flow, and what is uniform flow and non-uniform flow, laminar and turbulent, rotational and irrotational flow. So these are the very important to understand any system, especially this laminar flow. When the fluid is flowing in a smooth and straight line, that you can call as a laminar flow. When the fluid particles are moving in a zigzag fashion, that we can consider as a turbulent flow. So these laminar and turbulent flows we will also discuss in the third unit in detail. So after that, we will derive the very important equation in the fluid mechanics, that is continuity equation. So continuity equation we will derive, and after that we will try to derive the equation for continuity equation 1 and 2 and 3 dimensional flows. So later part we will try to understand what is the stream function and velocity potential function, and how we will use this stream function and velocity function in the flow net analysis. This is a very important concept which will be useful in geotechnical engineering. Try to understand the seepage flows or the design of the structures. So in the second part of the second unit, we will discuss about the fluid dynamics. In the fluid dynamics, so what we will do is, we will try to understand the fluid motion by accounting the force which caused the motion. So here we will not account the force which caused the motion, but here we will account the force which caused the motion. So here we will understand what is the surface and body forces acting on a fluid, and also we will derive the very important equations for fluid mechanics is Euler's equation and Bernoulli's equation. So we will try to derive the expression for Euler's equation and Bernoulli's equation. This Bernoulli's equation is nothing but once you derive the Euler's equation, after integrating it you will get the Bernoulli's equation. So next we will discuss about the momentum equation and how it is going to be useful in in fluid dynamics, and also we will derive the expression for force exacted by the flowing fluid on a pipe bend. So these are the concepts we will discuss in second unit. So when it comes to the third unit, here we will discuss about the laminar and turbulent flows. So here we will discuss about laminar and turbulent flows. So first we will discuss about Reynolds experiments. So generally this Reynolds experiment is helpful for to understand the for the classification of the flows, whether it is a turbulent, a laminar flow, a turbulent flow, a transition flow. And next we are trying to discuss about the characteristics of laminar and turbulent flows, and then we will derive the expression for shear velocity distributions, means shear stress distribution, velocity distribution, and also pressure difference between the two sections when the fluid is flowing between the in a circular pipe. And also we will discuss about the laws of the fluid friction, and we will derive the expression of the pressure difference by using a Hazen-Poiseuille equation, and also we will try to understand the flow through the long tubes or circular tubes, and then we will discuss about the flow between the parallel plates. And finally we will discuss about the hydrodynamically smooth and rough flows. In the second part of the third unit, we will discuss we will derive the expression for Darcy-Weisbach equation. First actually we will discuss about the minor and major losses in when the fluid flowing between the pipes. This Darcy-Weisbach equation actually helpful to find the loss of head due to the friction. So actually when it comes to the losses, there are two losses, major losses and minor losses. When the fluid is flowing between the pipe, there are two types of losses. One is major loss and minor losses. This major losses is majorly because of friction. This is majorly because of the friction. So here to find out the loss of head due to the friction, there are two equations we will use. One is Darcy-Weisbach equation and another one is Cheggy's formula. So this expression for the loss of head due to the friction we will derive in this third unit. And then in the minor losses we will discuss about the varied minor losses like loss of head due to the entrance of the pipe. For example, there is a tank and water is flowing from this tank to another tank here. So while the water is entering from here to here, so because of this entry there is some loss of energy that we will find out. And then once it is entered here, so there is a friction, right? So this is friction of the pipe will cause the resistance to the flow, that will be considered as a major loss. Here at the bend, because of the pipe bend there is some loss of energy, that we will consider as a minor loss. And when the fluid enter here, because of here also there is a bend, so then because of the bend there is a loss of energy. So when you connected a pipe, two pipes with different diameters, so because of this sudden expansion there is some loss of energy, that we will derive the expression here, that this is comes under minor loss. When the large pipe is connected to small pipe, because of this contraction there is some loss of energy, so that we will account as a minor loss. We will derive the expression for the loss of head due to friction because of the sudden contraction. And when the water is exiting from this pipe, there is a loss of energy, that we will find out in the minor losses. So then we will discuss about the pipes in series and pipes in parallel. So how to find out the total head loss when the pipes in series or pipes in parallel, and finally we will discuss about the total energy line and the hydraulic gradient line. So when we what is total energy line? When you join the potential head, velocity head and pressure head, that is called total energy line. If you consider only potential head and pressure head, that is called hydraulic gradient line. So that we will discuss, and also we will find out the variation of the friction factors with Reynolds number, and then Moody's chart. Pipe network problems, these are very important problems. We will discuss Hazen-Williams formula and Hardy-Cross method to find out the flows at various sections of the pipe network. So in the fourth unit, whatever the third unit, we will try to find, in the fourth unit we will try to find out rate of flow, or we will try to measure the flow rate in a pipe. So this we can do by Venturi meter or orifice meter or petard tube. Generally this Venturi meter or orifice meter we will use to find out the discharge, and petard tube is we use it to find out the velocity. So once you know the velocity, if you multiply it with the area, you will get the discharge. And also we will discuss about the classification of the orifices and how we can classify a small orifice, a large orifice, and etc. and flow over the rectangular, triangular, and trapezoidal and stepper notches. Okay, we will discuss about the what is the weir and notch and what is the difference between the weir and notch, and we will also discuss about the various we'll derive the expressions for the rectangular notch, a triangular notch, a trapezoidal notch, and also we will discuss about the broad crusted weir and bogey weir and narrow crusted weirs in detail, and we will solve some numerical problems related to measurement of the flow. So when it comes to the last unit, here we will discuss about the boundary layer theory. So what is the boundary layer theory and what are the basic concepts in boundary layer theory and Prandtl contribution and characteristics of boundary layer along with a thin plate and von Karman momentum integral equations, and also we will try to understand laminar and turbulent boundary layers, and what is the boundary layer, how boundary layer transition happens, and what is the separation of the boundary layer and control of the boundary layer, and flow around the submerged objects, and drag and lift concepts, and these are the important concepts for GATE exam also, and we will discuss about the Magnus effect. So these are the things which we will cover in the coming classes. So here almost whatever the contents covered in the 5 units are mostly covered in the GATE syllabus also, so it is very important for the GATE aspirants. So these are the textbooks we are going to refer. You can study hydraulics and fluid mechanics, including hydraulic machines by P.N. Modi and Saith, and also a textbook of fluid mechanics and hydraulic machines by R.K. Bansala. These are some reference materials, and also I will try to provide some online resources from the NPTEL courses. So there you can get more information about this subject. When it comes to the course outcomes, here after successful completion of this course, and students will able to understand students will able to understand the various properties of the fluids like density, specific weight and specific gravity, viscosity and vapor pressure, and these properties the students will able to understand, and their influence on the fluid motions, how the fluid properties will influence the fluid motion, and also they were able to analyze a variety of problems related to fluid statistics and fluid dynamics. So for example, when a plate submerged in a liquid, so how much force is exerting on this submerged plate, or where it is acting, and also the student able to calculate the forces that act on submerged planes and curves. This we will discuss in the first unit, and their ability to analyze various types of the fluid flow like steady flow or unsteady, uniform, non-uniform, one-dimensional, 2 or 3-dimensional flows, rotational, irrotational flows, laminar and turbulent flows. So the students are able to differentiate and are able to identify what kind of flow it is, and are able to analyze these flows. And finally, they are able to apply the integral forms of the 3 fundamental laws of fluid mechanics to turbulent and laminar flow through pipes and ducts in order to predict the relevant pressures, velocities and forces. So here the 3rd and 4th unit are majorly discuss about application of this Bernoulli's equation and continuity equation. So actually before going to the subject, I will tell you 3 concepts are very important to understand the fluid mechanics. One is the pressure, P is equal to rho GH. This is the one of the important formula. We will try to, this will help you to estimate the pressure at any point. Rho is the density of the fluid and G is acceleration due to gravity, and H is the head of the water available at any point. This is the one of the important formula that you should know before going to the fluid mechanics. We will discuss and we will derive the expression also in the first unit itself. And second important concept is continuity equation. This is the expression for discharge when for example there is a fluid flowing between 2 different points from one section. This is the section 1 and section 2, and the fluid is flowing between the 2 sections. So what the continuity equation will tell you is whatever the flow entering into the section 1 will be equal to the flow leaving to the section 2. This is the very important concept for the fluid mechanics. This you need to understand. This is for fluids which density is constant, and if the density is not constant, the equation will be rho 1 A1 V1 equal to rho 2 A2 V2. This is the second important equation that you should know. And third one is the Bernoulli's equation, that is means P1 by rho G plus v1 square by 2g plus z1 equal to constant. So this is a third important equation which you need to know, that is Bernoulli's equation, which is nothing but p by rho g plus v square by 2 p by rho g plus v square by 2g plus z1 equal to constant. This is the pressure head and velocity head and potential head. The sum of the pressure head, potential head, velocity head at any point is a constant. So these three equations will help you to understand the fluid mechanics in a better. We will discuss in clear. Yeah. Next one is so where we will apply this fluid mechanics. Normally it will help you to design the dams. It will help you to design the dams. For example, you want to design a dam. So what you need to know? First you need to understand how much the pressure exerted by the fluid on the dam. So if you are not able to design the force exerted by the flowing fluid on the dam, so if you design the dam for less than the force exerted by the flowing fluid, what will happen? It will collapse. So first we need to understand how much force exerted by the dam when the fluid is flowing, at the same time the fluid is rest. If you see, the most of the time the fluid is rest before the dam, because when you close the gates the fluid at rest. So you need to understand how much force exerted by the flowing fluid on the dam when it rests and at the same time when it is flowing, and also where it is acting. So that will help you to design the dam. And also spillways and hydraulic structures. So any kind of hydraulic structures, if you want to design in any kind of hydraulic structures, first you need to understand about how much quantity of water coming to that place and how much force exerted by the fluid. So that we can do by knowing the fluid mechanics. And also it will help you to design gas, water and oil pipe networks. So in the third unit we will discussing about the pipe network problems, there we will discuss. And then to study the water and air pollutions. To study the water and air pollution, first fluid means it is a liquid and gases. So we need to understand how the fluid is propagating from one place to another. So that will help you to understand the water and air pollutions. And also to design the bridges across the rivers, and also to understand the coastal engineering and oceanography. And also in designing the some slabs which has to resist the water and groundwater pressure. So there also the fluid mechanics will play crucial role. For example, if you want to design a dam, what will happen? If it is permeable soil, the water will percolate before the dam. So water will percolate, and what will happen? It will come at the downstream side. So which cause the reduction in the soil stability at the bottom of the slab, which may cause the sinking the dam. So to avoid that, so first we need to understand how the soil is water is percolating, or what is the seepage process happening. So to understand that, we need to know the fluid mechanics, and also it will help you to design the inshore civil engineering infrastructures. For example, here if you see, water is essential for our daily life, and we may not get the water directly from groundwater in most of the cases. So what we have to do, we have to channelize the water, right? The water has to come from the nearby river basin to our homes. So that we will do by constructing the canals. To design these canals, what we have to do, we have to provide a certain slope, and we have to know how much quantity of water has to flow and how much quantity of water has to reach to the end user. So for that, first we need to estimate the quantity of water. For that, fluid mechanics will help you, and also for designing the and providing the side slopes and longitudinal slopes. So these things we have to understand the fluid mechanics. Thank you.
So now you say next session we will continue so and so things like that. You continue.
Okay.
You say we will stop now, and next session we will discuss about so and so topic. You can tell.
Okay. Sir.
We'll cut it later.
Okay. Sir. Okay. Yeah, with this I'm going to close this session. So next class we will discuss about, first we will try to understand what is fluid mechanics and what is fluid, and what is the difference between the fluid and a solid, and a fluid and a solid, and we will also discuss about the fluid properties, as how to understand the fluid properties, and also we will try to solve some numerical problems related to fluid properties in the upcoming class. Thank you so much.